All right, here are solutions for perfect problem 4 from Math 213. We're given this crazy picture here and asked a bunch of questions about how much of stuff is shaded, but we're not given any lengths in this picture. But if you go and read through here, it gives you enough information that you can figure it all out, so we'll just kind of take it from the top. So in the diagram, this quadrilateral ABCD, this guy right here, kind of looks like a square. Guess what? It's a square. Points E and F lie on this line. Yep, they sure appear to. And they are 1/4 and 3/4 of the way from A to B respectively. So at this point you can introduce variables. You can say the length from A to B is, I don't know, X or something. But you don't have to. You have the freedom to call that length whatever you want. So a lot of people might think to call that 1, but then you're going to introduce a lot of fractions, right? If it's 1 from A to B, and this is a quarter, and this is a half, and this is a quarter. So I think it'll be easier to call. I will call the length of AB 4. And the reason I'm going to call it 4 is because since this thing is a square, then that tells me that this length right here is 4. Maybe I'm not going to label it like that. And if E is 1/4 of the way from A to B, a quarter of 4 is just 1. And F is 3/4, so that means this entire distance here is 3, but I used up 1 here, so I kind of have 2 in here. And if the whole thing is 4 and I got 1 here, 2 here, I must have 1 over here. Okay, points E and F, I got that. Point G is the midpoint of AD, so G is halfway from here to here, but I know here to here is 4 because this thing is a square, so therefore that's a 2, and that's a 2. The circle is centered at point F right here and passes through the point C. So what I'm going to do is I'm going to draw an extra line here. I'm going to draw a line from F to C. And that line right there represents the radius of this circle. But note that I can calculate that because I have a right angle right here. So I have a right triangle, and the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse, aka a squared plus b squared equals c squared. So if I call this like c right here, I know that 1 squared plus 4 squared is equal to c squared. So 1 plus 16 equals c squared. So 17 is c squared, and therefore c is the square root of 17. Technically plus or minus, but since we're talking about lengths here, it has to be the positive solution. So I get that this distance right here is root 17, and I think that'll end up being really useful because once I have the radius of a circle, I have a lot of information. The circle centered at F, we got that, passes through C, yep, sure appears to. Point C is the midpoint of JK. Okay, so here you might note that I have this radius, and this distance is the square root of 17. And that means that this distance is the square root of 17, so this entire distance is twice the square root of 17. But since HIJK is a square, if this is twice the square root of 17, this is twice the square root of 17. And since C is the midpoint of K and J, this right here is the square root of 17, and this right here is the square root of 17. I think that's all the information I'm going to need to go through and solve some of these questions. So what percentage of square ABCD is shaded? Well, square, this doesn't all have to be capitalized, square ABCD has area. Let's see, the area of a square is the length times the width. So the length is 4, the width is 4. So the area of this square is 16. It wants to know what percentage of this square is shaded. So what about this shaded triangle right here? Triangle, what do I call this? GEF has area, and the area formula for a triangle is 1/2 the base times the height. Well, if I call this the base right here, the base is 2, times the height, it looks like the height is also 2. So I get 2. So when it asks me what percentage of square ABCD is shaded, percent of ABCD shaded would be 2 over 16, which is the same as 1 over 8, which is 1.1 0.125 or 12.5%. No rounding necessary. So that takes care of part A. Part B. What's part B? Ask me. What percent of the circle is shaded? Well, I already know how much is shaded. So if I could just figure out the area of the circle, area of circle is equal to pi times the radius squared, which is pi times my radius is the square root of 17 squared. So it's 17 pi. What is 17 pi? Well, you can get a calculator to kind of approximate it if you want. So I'll go ahead and do that with this calculator. I got 17 times pi, which most calculators have a button on there. If I just hit enter, it says, yeah, that's about this. So, okay, this is about 53.4071 maybe, if I round it off to 4 decimal places. Does it tell me about rounding here? Round each answer to the nearest 1/10 of a percent. So that should work. So then percent of circle shaded. Well, remember the triangle that's shaded is 2. And the circle has area 53.4071. So if I grab my calculator and do 2 divided by that answer, it'll tell me the percent that's shaded. And it looks like 0.03744. In other words, 3.7%. Okay, and then finally, what percent of the big square is shaded? Well, that's not going to involve much extra work. All I need to know is what's the area of the big square, but I know that the length of a side of the square is 2 times the square root of 17. So area of square, what is it, Hij equals 2 times the square root of 17 squared, which is 4 times 17, which is 68. Yeah. Okay, so then the percent of the square that's shaded. Well, again, we know how much was shaded. The shaded amount was 2 from the very first problem. So it's 2 over 68, which I can get a decimal approximation by pulling a calculator back out. 2 divided by 68 is equal to 0.0294 or 2.9%. So those are my answers. I guess that answers all the questions. In each case, I rounded to the nearest 1/10 of a percent. So I'm going to go ahead and call this good.